Good afternoon. My name is Jérôme Poudvigne. I'm a startup solutions architect with Amazon Web Services. I'm originally based in Singapore. And today I want to welcome you to the Philippine Startup Week 2020. Before we start, I just want to take a moment. I've been a co-founder and a founder myself of multiple companies. And really, I would just want to congratulate you on the fact that this is really a difficult year. This is a difficult time. And yet you are embarking on this incredibly difficult but challenging journey. So my heart goes to you. Congratulations again. We love startups and we do anything we can to help them. And I just want to show you the tools we have for you to embark on a journey of machine learning, accelerate your journey, and have the most fantastic productive experience with it. While I'm talking, please feel free to use the chat at the bottom of the screen and ask questions and engage with myself, and I'll be very happy to address your questions. But in the meantime, let me start and show you a little bit what Amazon has to offer in machine learning. First, before I start on machine learning, I want to talk to you about where Amazon comes from. Machine learning at AWS and AWS itself is the result of three really big ideas. Put the customer first, invent and be patient. And this is an approach that is starting with the customer to enable innovation. This is rooted in a culture within the company, and it's just these few things. Customer obsession, right? Put the customer first. We always want to know what the customer needs. We do a rigorous work back thinking, which is once we know what is the favorite outcome, we go back and say, what do we need to do to achieve this? Inventive, yeah, inventive mind, yes, but you know that everybody has that. But why be patient? The be patient is because we understand that the failures are inevitable. And when you pursue invention, you will fail. You will meet things that don't work. You will have to iterate. So this is our mindset. We have a mindset to fail. We have a mindset to learn iteratively. And the long-term thinking that goes with it, being patient, is because we are very stubborn on the vision, but even if we fail sometimes, we will change the details. That's the whole key. Have the vision, be patient. And the innovation at Amazon keeps turning. We develop multiple innovations every year, right? Some of which sometimes see the light of the day and sometimes do not, or maybe not in their original form, like the last mile delivery, the advanced shopping, Kindle, Fire TV, Amazon Fresh, Amazon Echo and Alexa, and others. And one of the biggest one, which I wanted to talk about today, is Amazon Web Services. A bit of background, Amazon Web Services is actually the computing arm of Amazon originally. So it was born of the fact that Amazon got extremely good at building infrastructure for themselves. Amazon was expanding all over the world and had to build incredible knowledge and know-how in order to be able to sustain the online store. But after a few years, Amazon realized that we had acquired a significant know-how on how to just run data centers and run a global IT. And this know-how could be actually becoming a business itself. And this is how AWS was born, out of this realization. This is the cloud. And this is the on-demand delivery of computing power and services with a pay-as-you-go model. So it's just like a utility. You use the computing power, you pay, you don't use it, you stop paying. It's like electricity. You switch it on, you pay, you switch it off, you don't pay. The cloud, in essence, is this. You use computers, you stop using them, that's it. You only pay for what you use. What's important is that what sustains AWS is first a global infrastructure. You can deploy your virtual infrastructure in 24 geographical locations, which is marked in orange on this map. These are regional areas. Each region has redundancy built in. There are multiple independent clusters of data centers. We call them availability zones. They are all connected through our global infrastructure of networks because these multiple independent clusters don't break at the same time, hopefully. This brings the ability to build redundancy, create systems who are practically never down, and also because you can be anywhere in the world, you can bring computing and connectivity very close to your clients, which means that you even when your signal, your internet packets or your networking has to travel from your phone or your computer to a data center, there's always a data center which is relatively close, and then the network can bring the data even faster to the main data center. We keep adding regions, we keep adding zones, so the expansion is continuous. I just talked about using computing power. Okay, so what kind of computing power? There are a lot of variations on that, and I typically like to split this in two groups. The building blocks. The building blocks is computing. So computing is essentially, you can think of it as a computer, as virtual computer. It's machine, a CPU, some memory, disks. We also have storage, which allows you to store extremely large quantities of data, so videos, files, text, documents, anything that can be stored as a sequence of binary data. Networking to connect all of this, and of course security, which make sure that only the right people have access to this. Actually, even databases today are almost like a building block, so I included in them. They used to be considered as very sophisticated, their own kind of software, but right now there's very few things that don't use a database, so having a database is almost a given. In addition to this, what is very interesting is we build synthetic services, higher order services, who are systems that potentially one could build for themselves, and they would be quite complex to build. But what we do is we build them for you, we maintain them for you, we run them for you, we secure them for you. So basically, you make it our problem. And that allows you to save a huge amount of time and energy focusing on the real creative part of your business and whatever is your differentiator. You don't need to spend too much of energy installing hardware, installing operating system and patching for security and so forth and so on. You just ask us and you get a full-fledged search or a full-fledged IoT service. Amongst all of these, there is machine learning. And so I'm going to see a little bit how all of this fits in our landscape. Of course, I need to first, explain what is the big deal about AI and ML. Machine learning. Machine learning went from being something that was aspirational, that was something that was, in the research labs, and that was something that was really reserved to very large corporations and, major tech companies, hardcore academic researchers. Now with cloud, with the advances in cloud and the advances in computing power, the fact that computing power is really much cheaper, then it becomes really available. Data is also very largely available, and machine learning is actually making an impact across every industry: finance, fashion, real estate, healthcare, etc. Anything. It's just ubiquitous, and it's moving really from being at the periphery as a nice addition to what you are doing to being part of the core of what you should be doing. Companies are spending. So by 2021, the spending will be exceeding 50 billion. At the end of 2024, 75% of enterprises will have shifted to operationalizing AI, and 57% companies say that they would adopt AI within the next 3 years. So this is actually not anymore a small technology, it's a whole movement. And we see this. We see this at the tipping point. AI/ML in the enterprise is addressing use cases that create really measurable results. Customer experience is being transformed. You have capabilities such as conversational interfaces, biometric authentication, personalization, recommendations. I will talk a little bit more about personalization. Business operations are improved. Sophisticated demand planning, forecasting models in retail, in automation for supply chain management, in transportation, in optimization of truck transportation. It's also helping companies making better and faster decisions. In healthcare, we see a shift from reactive to productive, so predictive. So for example, you can see that now we start using predictive model to anticipate the need of patients or to accelerate research. And the AML is basically helping companies creating new products, services, new business model to innovate and gain competitive advantage. So let me zoom a bit on our AML services. We have the largest offering today with the deepest set of tools. I'm just going to stop one more time before diving into it, which is I say AI/ML, and people usually say artificial intelligence or machine learning. There's a difference. It's actually a subject of a very strong academic debate. For the purpose of this presentation and for the purpose of all practical purposes, this is what Amazon Web Services has adopted as a sort of definition. So artificial intelligence is a way to describe any system that can replicate tasks that previously required human intelligence. Almost always, this is related to some kind of decision making where human judgment would be required. Most use cases for AI are looking for a probabilistic outcome. So making a prediction or making a decision with a certain degree of certainty or the degree of probability, a bit like human judgment. Almost all AI systems today are created using machine learning. Like the name implies, machine learning is a technology where you can teach the computer how to infer results by showing the computer a series of examples. And you use a large amount of data to create and validate this logic. This decision logic is called a model, and the AI application will just feed this into the model, and the model will output a decision, which also we call a prediction. So machine learning is the technology that underlies this. And deep learning, that you probably have heard about, is a type of machine learning. There are many types of machine learning. Deep learning is one kind of machine learning. It uses a technique known as deep neural networks. This is a system which replicates or simulates simplified human brain function. So it lets the system address very, very complex problems such as we were not able to do before. It was really not previously possible. So these are the three things to have in mind. And in each of these AWS excels, that actually is what I want to really discuss. And this is really what this distinction is the way we actually split our own products. So without further ado, let me show you a little bit how we are innovating on behalf of our customers and how we split these various problems. We have the broadest and deepest set of machine learning capabilities. We have for builders at all levels of expertise. And as we see, we keep it in 3 layers, which actually sort of incidentally map my definitions. You have the top level, which is AI. It's systems that behave in a way that seems to require judgment. So deeper to this, you have system where you actually build yourself the model. And at the lowest level, you have the deep learning and other systems where you actually need to be really involved in programming and even specific hardware. So let me walk you through these layers. We think about machine learning at the bottom level as the domain of the deep experts, right? You have frameworks, interfaces, infrastructure. This is for machine learning practitioners, people who actually write code and write new technologies. So they will need what we call frameworks. They will need special hardware. They will need GPUs and CPUs. They will need a number of libraries. We offer the most popular libraries ready-made for you. So for example, TensorFlow is the one that has the most resonance today. It has the largest community, and we have a lot of TensorFlow experience. In fact, 85% of TensorFlow runs on AWS. In general, machine learning practitioners use more than one framework. So they also develop new algorithms all the time, different frameworks. So in fact, instead of having just one framework, we provide many of them. We have dedicated teams for every of the major framework. And so you have the right tool for the right job. There is not many of these machine learning practitioners. Actually, if you want machine learning to be pervasive, you have to make it easier for everyday developers and data scientists to build, to train, to tune machine learning models. And that is the middle layer of the stack. And I will actually talk a little in greater detail about it. We provide a system that allows you in a single environment to perform a number of very disparate tasks that used to be very complicated to put and chain together. And this is the middle layer. This is where people develop models and tune models. This tool that unifies everything is called SageMaker. This is a managed service. It provides every developer and data scientist all the abilities to perform activities around the machine learning models. And it also allows you to build end-to-end machine learning workflows. And that means from the inception to getting to production, it's a lot faster. I'm not going to be too technical, but really, I just want to illustrate that traditional machine learning development is very complex. It's expensive and it's iterative. So until SageMaker was available, it was on top of that more further complicated by the lack of integrated solution. Every step required specialized tools who didn't necessarily work well together. And then you had to sort of hook them together in an ad hoc fashion. This was very complicated. This was very error-prone. You had to stitch together all these tools. So first you had to select the algorithm, select the framework to build the model. Then you have to train the model on how to make predictions. You have to tune it to deliver the best predictions. And then you have to integrate the model with your application. And then you have to deploy this application on an infrastructure that needs to scale. So this is already, each of these tasks is actually a complex task in itself and used to require a specialist. Complicating this, many of the tools that you take for granted when you develop software, such as debugger, such as collaboration tools, such as product management tools, and so forth, they are disconnected. They don't really work when it comes for machine learning development. So, for example, there is one system called Notebook. It's very popular. It's great for an individual developer, but it's very hard to share them with peers. So typically, developers do not work alone. So that is actually an issue. How do you work collaboratively with another developer on the same project? Another example is model tuning. Model tuning can take days, can take weeks of very tedious work. So typically, to tune a model, you start with a random choice, and then you iterate. It can be really, really, really long, and it requires adjusting thousands of combinations. You not necessarily have all the tools available. This is actually a different technology. With SageMaker, this is a fully managed service, and it removes all this heavy lifting from each step. So it will give you a fully managed data processing job. It will allow you collaborative notebooks. It has a one-click development, one-click auto-scaling. It removes a lot of these barriers. And since the launch, we keep adding new capabilities. So it's an all-in-one system. In our language is called an IDE, an integrated development environment. This is a term that you encounter more frequently in the world of software development, but actually this is exactly the same idea. IDEs have everything you need in one system, and SageMaker is exactly an IDE for ML. This is in one slide a little bit why SageMaker makes ML easy, machine learning easy. You can access all the components you need to build, train, deploy machine learning model in the world's first IDE for machine learning. One-click training and deployment. You just specify the location of your data in our storage system. You indicate the type, the quantity of instances you need for SageMaker. SageMaker will set up a distributed cluster, who do all the computing, perform the training, output the result. And it will tear down the cluster when it's done. If you remember what I said at the beginning, when you start a cluster and you use computing, the cluster has a cost. But when you're done and you tear down the cluster does not exist, you stop paying. You didn't have to provision a computer that you keep paying in your warehouse or your data center while you are not using it. Then you can, after you're done, you can actually one-click deploy your model in an auto-scaling compute instances in multiple regions. You can set up secure HTTPS endpoint. It will be all done automatically. We also provide built-in algorithms that you can use readily. You can develop your own, or you can use popular frameworks, including TensorFlow, PyTorch, scikit-learn, MXNet. And it will also provide the automatic hyperparameter tuning. So how much does it cost? It's difficult to say how it costs because it's a pay-per-use, but what we know is that it significantly lowers the total cost of ownership over a 3-year period by at least 54% compared to other cloud-based machine learning options, such as self-managed. Self-managed meaning instead of using Amazon SageMaker, you will actually assemble your own tools. It will help you also reduce the cost. Data labeling can be done, can be done using ground truth. It will help you to get that ground truth for training data. Elasticity is really important. Elasticity is the concept that the more computing power you need, the more the system will allocate it power. And then when you don't need power, it will actually reduce the amount of power you need. And security. Security is built in. SageMaker allows you to operate on a fully secure machine learning environment from day one. There's a very complete set of security features, including infrastructure security, access control, data protection, and many compliance certifications. So this is really a complete tool that takes care of the whole life cycle of machine learning, from the inception to the deployment in production, all fully secure, and allocating resources as needed, and turning them down when you don't need them, so optimizing your costs. Now I want to move to another part of our offering, which is the AI services. So as we said, AI services is really a system that I call ready-made intelligence, is something where you don't have to be a practitioner. In everything I showed you until now, you really need to understand ML, at least at a relatively deep level, or sometimes you need to really be an expert. But sometimes you don't really want, or you don't really need, and machine learning practitioners are very hard to find. You don't want to have to pick a practitioner. All you really want is the feature. And this is what we are providing you. We call this AI services. If you remember, at the top of my stack, at the top of the previous diagram, this is this stack of products who are solution oriented, and you just want to add intelligence and solution orientation to your application, but you don't want to develop and train your models. And this is most of the systems we use. So for example, you want to do recognition, like for example, going from the top left. Tell me what this image is. Is there a celebrity in this image? Is this image safe for work? Is this person in this photo or this photo, right? Speech with Poly and transcribe. If you want to turn text into speech, there is Poly. If you want to transcribe audio, we have transcribe with a special edition for medical speech. Text, you want to translate text into different languages, we have translate. You want to understand what's being said, you have comprehend. You want to extract text from documents, you have textract. So I could go on and on. The only distinction I would do is that there is really ready-made tools that you can just activate and use. For example, image recognition. There are tools that I'm going to go over who are ready-made algorithms and product, but they still need to know your own information. For example, personalized or forecast or fraud detector are tools who are going to work on your e-commerce shop or on your past time series of inventories. That are tools that need to know the content of your catalog. If you are doing a personalization for your online store, Amazon Personalized needs to know the history of your purchases and what you are selling. Once you have programmed the system with this, then it will be able to serve recommendations. So there's an additional intermediate step. So this is ready-made intelligence that still need to be adapted. And you also have, but the left part of the diagram is ready-made intelligence that needs no adaptation. It is available out of the box, off the shelf, activate it, and you just pay per use. If you pay per number of images you process, you pay per number of sentences you translate. It's very simple and straightforward. I'm just going to show you a couple of capabilities. I'm not going to go over every of these products, but this one is actually fun. So Amazon Recognition. Amazon Recognition, it makes it very easy to add image video analysis to our application. It uses proven technology. It requires no machine learning expertise. You can identify objects, you can identify people, you can identify scenes, text, activities in images and videos. You can detect inappropriate content. So use cases are multiple, right? For example, if you are broadcasting, I don't know, videos and people upload their videos to be broadcasted, you can make sure that these videos are safe or don't have anything illegal or don't have anything that is not suitable for a certain part of the audience. You can use facial in another application is to use facial analysis. You can use facial analysis, facial search capabilities. You can detect and analyze, compare faces. So for example, you could have people who register for a race, a marathon, and then you just need to take a photo at specific parts of the race, and the system will be able to recognize who is there, and then will be able to time the people or decide when they have passed the finishing line. You can do people counting. You can do a lot of additional features. So basically, it was launched in 2016. That's it. You just need to use it, activate it, and you can do all of this, analyzing images at scale, machine learning, a single API call, no PhD required. One more little bit of example, you can see here what is facial analysis, the process of detecting a face within an image and then extracting relevant attributes. So you will see that this person has the eyes open, has a certain, is smiling most likely, or sort of smiling, looks generally happy, and then the system will be able to detect the position of the eyes, the nose, if that person is holding their head vertical or not. It will also be able to recognize sunglasses and other landmarks. You can detect the similarities, so you can see that the system will be able to detect which of these people are in both photos with a good probability. This is just one API call again. You can use this to verify a person's identity against their photo and file in near real time. Another application that is actually a complete system. So now I'm moving to the systems who need to know your data. So the intelligence is already there, but it needs to know your data. For example, enterprise search. Today, in a company, your knowledge is in many silos, right? It's in unstructured data. You have email, you have presentations, you have databases, you have web servers, you got stuff on Dropbox, you got OneDrive. It's all mixed and it's all isolated. Canra is a system that makes everything easier by just scanning all this data and then analyzing it and providing really much deeper content analysis. So you don't say anymore, If your laptop is broken, you can just go to Canada and say, where is the laptop repair? You don't have to enter a specific sentence or click through a series of links to find the result. Another one that is born out of Amazon's own experience, fraud detection. Building machine learning models for fraud detection is actually pretty tricky. It's pretty important. If you are selling anything online, for example, it's actually something that's extremely useful, but it's not the only domain where fraud can be pervasive. So fraud teams usually do not have in-house ML experts, and so they have to borrow data scientists or experts from other teams. They usually, the first thing is to rely on rule-based systems. So if this credit card is from this country, then it's suspicious. If it's not from this country, then it's not suspicious. When the reality is actually way, way more subtle. You have manual fraud reviews who are expensive. So based on this, AWS built a system based on our 20 years of experience of detecting fraud at Amazon.com. AWS has built this system, and it's only, again, available. It provides you tailor-made fraud detection, machine learning model for this, for online events like e-commerce orders and account registrations. You just upload your data, you train the machine model on your data, and then you configure just the decision logic. It boosts the model performance by actually keeping up to date on how the customers, how the historical customer fraud data and the past attempts to defraud. So it's a very powerful system. It's all available with a few clicks, and we need to provide it some data, but it will be available very fast. I just want to step back. This is our ML stack again, and now I'm going to actually, I said AI services at the top, the one who don't require any PhD in machine learning. Machine learning services will require you to be knowledgeable, but to be a machine learning practitioner. An ML framework would requires you to be a deep expert and very something that is very uncommon and hard to find. But we have tools for all of you. Now I want to focus on this one, personalized, because it's something that is an extremely good example of how Amazon Web Services took the experience of Amazon and included it in our own product in the same ideas, invent and listen to customers, as I mentioned at the beginning. You probably have been on any website that has e-commerce nowadays, and it's very common to see personalization experience, which is basically improving the discoverability of the other articles. So early features we had, like customers who bought this also bought that. It was actually very appreciated by all. It was really a great success. And since then, we have actually expanded all these techniques to refine it to a very large extent. Now it takes many forms across Amazon.com. You have Prime Video, Kindle, Amazon Music, and it keeps getting better. So from a tiny little widget that was showing people who bought this also bought that, the recommendations have actually come a very, very long way. We use many customer touch points. We recommend items based on your carts. We recommend items based on your recent browsing history. We have recommendations based on categories that are of higher interest because we know your click tracking, we know your history of browsing, we know the user experience across all Amazon properties, so your user experience is also personalized. And so it's commonly, thought in context of display channels, but actually it's very useful when we deliver it over email, over notification channels. So where are we today? It gets better. We have continuous advancements in machine learning research, very sophisticated deep learning techniques that can understand customer needs at the right time and within the right context. And machine learning models were optimized for a very wide variety of use cases like shopping, music, video, ebooks, etc. How does it work? So we aim to give you out-of-the-box solutions for foundational use cases for personalization. You can use these capabilities to generate a broad array of user experience. You have personalized recommendations, related items, so similar items to a selected item, and personal re-ranking. User personalization. This is an example of from Prime Video. We are recommending video from the Prime catalog. Similar items. This is the one that is people who view this also view that, right? This is the e-commerce workhorse. This is an example of what you have on screen when we are recommending rugs based on the particular rug that I have selected on Amazon.com. And then you have personalized re-ranking, which is re-rank a list of items. So re-ranking means if I look at this item or these items, what does the system will return me a classification saying based on this users, the knowledge of these users, I think this is the list of order of preferences the user would have. So I'm getting here a recommendation from audiobooks in the classics category based on the list of audiobooks available. How do you build this? So where is the challenge? Why do you need machine learning? Most customers start from a rule-based personalization. So for a shoe retailer, we recommend boots for women visiting your site in November. Now, they make intuitive sense, but it really gets really hard to manage when the number of users increases, when the number of items in the catalog increases, because if you start selling more boots and shoes, and then you start selling books and you start selling other things because your retail store is expanding, it becomes very complicated to manage rules for everything. It becomes very difficult to have rules that are specific enough to user segments. So it's not really personalization anymore. And actually, even the human effort increases proportionally with scale, right? Now, one person, if you increase the number of items by 10, then one human will have to find rules for these 10 items, multiplied by the number of segments, multiplied maybe by a few additional parameters. So it becomes completely explosive. Humans cannot cope. So the best approach is actually to have something that can build this model faster than humans. And the one that works the best is machine learning. However, it is not straightforward. Also, there are multiple challenges. The recommendation system, should respond to the intent, to the changing intent of users, right? You cannot have pre-computed recommendation, right? So it should also handle cold start. In cold start being you have never seen this person. It's a new user, or it's a scenario with a new item. For a rule-based system, it's very easy, but actually for a machine learning system, it's complicated. Recommendation, you shouldn't fall into the popularity trap, right? It's very easy to build a model that is very naive, which recommends mostly popular items, right? But it's hard to show a model that shows exactly relevant recommendation for non-popular items for a specific population, right? There is no master algorithm. Okay, there are some other machine learning applications where you have one algorithm that kind of is the only one. In this case, there's no master algorithm. You don't have a single one that solves all the sub-problems. And yeah, it's machine learning 101, but actually good personalization is very hard. So personalization is a basic personalization is relatively easy to build, but a good one is really difficult to build. So we found that machine learning experts are needed for building good models, right? So the combination of these challenges mean that most customers stick to rule-based, or actually they don't do personalization at all. But we build personalized for this. delivering high quality recommendations, adapt to the changes of the customer intent in real time. So when the data is fed into the system in real time, and it will readapt. You can retrain it. You can train a recommendation model with a few clicks, and you can generate recommendations for almost anything. It doesn't matter. The system doesn't actually specifically deal with cars or books or shoes. It deals with just anything. How do? You start by providing data about your users and the items to personalize. Activity of users, so interactions, events. Examples are, for example, clicking on purchasing, clicking on what they are watching, and the events you choose to send us will be dependent on your business domain. The second one is details about your items, right? Price, category information, anything that is in your catalog. It's optional, but it's very useful for cold start. The third data set is more detailed about the user themselves, like location, age, etc. Once you have all this data, in a few clicks, you can have Amazon personalize, fire up all the resources to train the model, and what you get a custom private personalization model. It's trained, it's hosted for you. And then you can actually get recommendation for your online shop or for your application directly through a private API. So just 3 things: activity, detail about your activity of your users, details about your items, and details about your users, so demographics and location, for example. And that's it. You get a working recommendation engine. This is what happens under the hood. I think it would be much better if you check our website for this. This is exactly a visual way to present what I explained. Just upload the data set, just install event ingestion, and get the data, get the campaigns. As you can see, this is a very short list of clients. You can use personalization in almost any domain, right? From pizzas to fashion, to motorbikes, to online classes, to selling sandwiches, to musical instruments. Everything is possible, and customers keep finding new applications. So I encourage you to think about how would you be able to include this in your systems. Let me move on to another system, which is also inherited from Amazon. It's called Forecast. So it offers you the forecasting expertise of Amazon's years of building the world's largest e-commerce website. And it's a managed service. Managed service is shorthand for you make it our problem. You just give us the data and we will just provide you the system. We built a very sophisticated machine learning forecasting algorithm over many years. And you can now use it without having to know anything about machine learning. So let me show you a little bit how it works, because you can use it in just about any industry. Right? What is forecasting? The science of predicting the future. You examine the historical trends, and you can make a call on what might happen and when. And you can build this into your future plan for everything from product demand to inventory to staffing to others. Given that the consequences of forecasting and the accuracy really matters, right? If the forecast is too low, then you will under invest or under provide, and then you will have a shortfall or a shortfall in inventory. If you forecast too high, then you will have too much products, you will have too much staff, you will have too much unused capacity, and then this is a wasted investment. So today's company will use everything, anything from transportation to raw materials to financials. Companies try to forecast today with spreadsheets, financial planning software, but the high accuracy is still not really there. It's very elusive. what we do is we group scenarios in 4 categories. You want product in stock, you want them immediately available. And I use product in a very broad sense, right? In the sense that it could be things it could be ready-made, fabricated product, it could be raw material, it could be anything. You want this in stock, you want it immediately available. You would want minimal total inventory, and you want also no unutilized labor, no uncapitalized infrastructure, right? So depending on the product, you can plan, you will plan your workforce, you will plan your inventory, you will plan your planning, you will build new fulfillment center, you would want to estimate seasonal peaks, you want to estimate alternative for new capacity. All of this, if done wrong, is something that can substantially impact your business. This is why you need a really excellent forecasting to prepare your business. We deliver this as a fully managed service. It automatically sets up data pipeline, data training, prediction, automatically provisions and clean resources. Again, it's elastic, highly available across many regions. It's highly accurate. It's the same machine learning technology we use at Amazon. It's about 50% improvement in accuracy over traditional methods. It's simple and easy to use. There is no deep learning experience required. There is no PhD required. You don't need data scientists. You just need a properly organized list of historical data. And it's your data and it's your model. So you basically train the system based on your own history, and forecast is customized to your data. Data is not shared with any other AWS customers, and the data is anyway encrypted through customer keys if you want. So when it's encrypted with customer keys, it means that even AWS cannot access it unless we have the keys. You can keep the keys, and we even have no access. So it's really the highest possible confidentiality. Quick look on how this service works. This is actually pretty much always the same story, so I'll go a little bit faster. You don't need any expertise. You will give us historical data. You will give us related data, so price, promotions, anything. And you give us item metadata. Item metadata is items like the color, the city, the country, the category. Input a built-in data set. You select the time horizon for the forecast. The system will build a model, and then you get a private forecasting API, which will allow you to generate forecasts on demand through your own system. There are many additional things you can do. Like, for example, you can select related time series who are provided by Amazon. Like, we will provide you holidays for different regions because we have this data. You don't need to go and fish for it. And unlike most other forecasting solutions, we don't generate just point forecast. We generate probabilistic forecast at different quantities. So it allows you to choose a forecast that actually suits better your business. It depends on whether the cost of capital or the missing customer order is of importance. So you can actually adjust the parameters and make the best decisions. You can view all this information in the console, and you can retrieve them through an API command. One very classic case we had was Peugeot Sound Energy. I'm going to ask you to cut this one. Sorry about this. Okay, forecasting is not limited to product demands. Customers all across the industries are using forecasts, for a large range of scenarios, from inventory planning to flight ticket price, ads impression, how many cash you put in an ATM, what is going to broadband usage, price of crop. This is an incredibly rich field. But in any of this, ultimately, the machine learning knowledge is the same. by properly customizing your system, by providing your data, you will have superior forecasting for any of these domains. Anything I forgot to put on this slide, of course. So I want to come back to my main takeaway. The mission of AWS is to put machine learning in the hands of every developer. Whether you are a deeply knowledgeable ML practitioner who are building models through notebooks and deploying them, whether you are interested in AI services, so you want to do machine learning without a PhD or just use built-in intelligence, or whether you are actually an ML developer and you're using TensorFlow and MXNet and using GPUs and CPUs, specialized GPUs and specialized CPUs, and you're interested in deep learning AMIs, deep learning containers, specialized hardware, we got you covered. We have the broadest set of capabilities in machine learning. We're ready for you. I'll give you here a few of our resources. I encourage you to go and do some reading on our website. I leave this up for a minute. So I really want to thank you to have attended the talk. This was like a whirlwind tour of what Amazon Web Services offers you as machine learning and artificial intelligence. There's a lot more to it. There's way more than in a simple 1 hour talk. So I really encourage you to get familiar with this website, get familiar with these pages, and eventually you can contact us or contact me. If you are interested, you want to get on board with our machine learning, or you want to just have some additional information, please be in touch and eventually follow me on LinkedIn. And thank you and enjoy the week.